Welcome back to Neural Intel, everybody. Let's dive into a pretty big question today. Can AI really code entire software projects from scratch?
It's a huge question. Honestly, a lot of the discussion has been pretty speculative, but some researchers decided to put it to the test
Put it to the test how?
with a brand new benchmark. It's called ProjectEval.
Project Evo. Okay, so this isn't about like an AI writing a simple function. We're talking about building a whole project, like from the ground up.
Exactly. Think websites, console applications, that kind of thing. Project level coding, not just like little isolated tasks. It was created by researchers at the Harbin Institute of Technology and Pengcheng Laboratory. And it's designed specifically to see if AI can handle those complexities of building a complete functional project.
That's a pretty big jump from what we've seen before. So how does this Project Evo thing even work? Do you just give the AI like a prompt and say, go build a website?
Well, it's more structured than that. They actually have three different levels of input. Each one is a little more complex than the last. Think of it like levels in a video game.
Okay, I like where this is going. Level one, hit me.
Level one is the simplest. The AI gets a basic natural language prompt like create a website for a to-do list. That's it, just a high-level description.
So the AI has to figure out everything else, the design, the features, the whole nine yards?
Exactly. It has to come up with the whole project from that one prompt. Then level two. Here, the AI gets a more detailed checklist of features. It's still written out in natural language. So for our to-do list website, the checklist might say things like, the user should be able to add tasks, mark tasks. Well, here's where it gets really interesting. Even the most advanced AI models like GPT-4 struggled to pass ProjectEval.
Wait, really? I thought GPT-4 was supposed to be this coding superstar.
It is impressive, but building entire projects is just a whole different ballgame. Currently, only GPT-4 managed to get a pass rate above 10%, and that was with 5 attempts per task. And remember, this is GPT-4, like one of the most advanced models out there. Open source models did way worse.
So all those headlines about AI replacing programmers anytime soon might be a little premature.
Yeah, it seems that way. What I find fascinating is that Project EDAL doesn't just give you a pass or fail score. It actually offers some really valuable insight into where the AI struggles in the process. We can start to understand what aspects of project level coding are really challenging for these systems.
Ah, you're talking about explainability. We love that here at Neural Intel. So what kind of insights did they uncover? What tripped the AI up?
One of the most surprising findings involved the difference between what they call cascade and direct generation.
Cascade and direct. Okay.
So in cascade mode, the AI generates code step by step, kind of like how a human programmer might work. Direct mode, on the other hand, is about generating the whole project at once.
I would think direct generation would be faster, but maybe less accurate.
That's what they thought too. And for most models, cascade generation did lead to better results. But here's the cool part. GPT-4 was the exception. It actually did better with direct generation.
Wow, that is wild. Do they know why?
We can only speculate at this point. It could be that GPT-4's massive scale allows it to hold the entire project context in its mind more effectively. Like, it can see the big picture and just generate all the pieces at once, whereas other models need to break it down into smaller chunks.
It's like GPT-4 is thinking about the code in a more holistic way.
Hmm.
That's a pretty mind-blowing concept. I wonder if this points to some kind of fundamental difference in how these huge, large language models approach complex tasks compared to their smaller counterparts.
Absolutely. And remember, Project Evil's layered approach with the three levels of input is really helpful here. By measuring performance at each step, the researchers could pinpoint exactly where the AI was stumbling. Like, for example, they found that turning a detailed checklist into a code skeleton was a major bottleneck for a lot of models.
That makes sense. Translating those human-readable requirements into structured code. It's a big leap, even for experienced programmers. It's like turning poetry into a set of instructions. You need that creativity and precision.
You're right, it requires understanding not just the individual instructions, but also the logic and the overall structure of the project, which is something it seems a lot of these models are still struggling with.
It sounds like ProjectEval is giving us a whole new way of looking at how AI approaches programming. It's not just about seeing if they can code, it's about understanding how they think about code at a much deeper level.
Exactly. And as AI programming gets more and more sophisticated, these kinds of benchmarks are going to be crucial for guiding its development.
So it's like a roadmap showing us where the AI excels, where it needs to improve, and what directions we might want to explore in the future.
Precisely. And speaking of areas for improvement, even though ProjectEval is a significant step forward, it's important to remember that it's not perfect. No benchmark is. And the researchers themselves have acknowledged a few areas where it could be expanded or refined.
Well, no system is
Oh,
perfect, right? So let's talk about those limitations. What are some of the areas where ProjectEval could be improved or expanded?
one of the main limitations is the current focus on web development using the Django framework. Now, Django's popular, but it doesn't represent the full diversity of projects out there in the real world.
So it's kind of like judging a chef's abilities based on just one type of cuisine. Like they might be amazing in Italian, but can they also bake a souffle?
A perfect analogy. Another limitation is that all the AI agents are required to output code in JSON format. Now, while this helps with standardization, it could be holding back models that might naturally excel with other formats.
It's like forcing a painter to only use primary colors. They might be able to create something,
Yeah.
but it's limiting their full range of expression.
You're getting it. And it's important to remember that Project Eval is still relatively new. As more researchers use it, I think we'll see ongoing efforts to address these limitations and make it more comprehensive and really push the boundaries of what AI can do in the world of coding.
Which is exciting. Because even with those limitations, we're seeing AI tackle problems that would have seemed like science fiction just a few years ago. This is cutting-edge stuff.
Absolutely. It's a snapshot of where we are right now, and it's a pretty remarkable picture.
It really does make you think about the future. If AI is already grappling with these kind of like relatively simple projects, what breakthroughs will it take before we see it building truly complex applications, like operating systems, or maybe even AI that can design and build other AI systems?
That's the million-dollar question, isn't it? And it's
Yeah.
one that Project Eval helps us frame in a more concrete, measurable way.
This has been an incredible deep dive already. I'm excited to hear what else you have to share about ProjectEval.
Let's keep going. In the next part, I want to talk more about how Project Eval goes beyond just those pass-fail scores and actually tries to simulate user interaction with the generated code.
That sounds fascinating. Don't go anywhere, listeners. We'll be right back after a quick break.
Yeah, it really is mind-boggling when you think about it. One thing that really struck me about Project Eval was this focus on the user's experience. Like, it's not just about whether the AI can spit out lines of code, it's about whether that code actually works for somebody using it.
That's a great point. I mean, you can write code that technically works, but it's a nightmare for a user to actually interact with.
Exactly. And that's where these test suites come in.
The test suites.
Right? Remember how we talked about those parameters? Well, instead of just running like basic unit tests, they actually simulate user interactions.
Okay, I'm intrigued. Give me an example.
So let's say the AI built a website. The evaluation process would mimic things like a user clicking buttons, filling out forms, navigating between pages, all those sorts of things.
So it's not just passing a technical test. It's like passing a real-world test.
Right. It's a much more realistic assessment of whether the AI is building something that's actually usable and user-friendly, which, when you think about it, is the whole point of software development.
It also makes you wonder, though, like, how do we evaluate AI-generated code in the future if we're moving beyond just those simple pass-fail metrics? Like, how do you account for things like user experience or design? Those are pretty subjective.
Absolutely. And that's something I think the whole research community is still grappling with. Like, those traditional methods might need a serious overhaul if we want to keep up with AI.
We love a good challenge here on Neural Intel. Now, before we move on, I wanted to touch on something we mentioned earlier, how ProjectEval compares the AI's code to a human-written solution.
Yes. That's where those objective indicators come in. They use algorithms, things like code BLEU, which essentially calculate how similar the AI's code is to the reference solution in terms of structure and syntax.
So it's like a plagiarism checker for code. Except in this case, we want the AI to be similar to the human version.
Exactly. It's a way to assess how well the AI understands, those programming conventions, best practices, that sort of thing.
And I'm guessing based on those low success rates we talked about, there's still some room for improvement there, especially for those open source models.
For sure. But it's important to remember this is just the beginning. As more researchers adopt Project Eval, we're likely to see these systems get better and better at adhering to those standards. It's like any new skill, The first attempts might be a bit rough, but with practice and feedback, things start to click.
Practice makes perfect, even for AI.
Exactly. And the insights from Project Eval are providing that valuable feedback, showing us not only what the AI is doing well, but also where it's stumbling, which is crucial for future development.
Okay, that makes a lot of sense. Now I'm curious, if AI is going to become more of a partner in software development, How do we make these benchmarks and these evaluation methods accessible to developers who might not be AI experts?
That's a fantastic question, and it's a real challenge. If we want AI to be a tool that empowers developers, we need to bridge that gap somehow, like create intuitive interfaces and visualizations that can communicate these complex evaluations.
I like to think of it like this. I might not need to know how a combustion engine works to drive a car, but I definitely need a dashboard that tells me how much gas I have and if the engine's overheating.
Perfect analogy. And luckily, that's what we're starting to see emerge in the AI tooling landscape. Platforms that abstract away the complexities of AI training and evaluation, giving developers the insights they need without needing a PhD in machine learning.
That's what we like to hear. AI tools for everyone. So you're saying this could really democratize AI programming?
Absolutely. It's not just happening in research labs anymore.
Yeah. That opens up a lot of possibilities. Imagine AI pair programmers suggesting code snippets in real time, or maybe even AI architects designing entire system architectures based on some high-level requirements.
It's a fascinating future to imagine, right? And while we don't have all the answers yet, Project Evil is definitely giving us a glimpse of what might be possible.
Speaking of glimpses, I wanted to go back to something that really stood out to me earlier, GPT-4's success with that direct generation. Were there any other, surprising or counterintuitive results that emerged from this research?
Oh, definitely. One interesting observation was that just being able to generate code that looks structurally similar to the human written version didn't always mean higher pass rates. Like sometimes the AI agents produce code that looked good on paper but failed to execute properly during testing.
So it's like a student who can memorize formulas but doesn't really understand the underlying concepts. They might ace the multiple choice test, but struggle with the application problems.
Exactly. It highlights the importance of moving beyond those superficial measures of code quality and really focusing on whether the code achieves what it's supposed to do in practice.
Which again brings us back to that user-centric perspective. If the code doesn't work for the user, it doesn't matter how elegant it looks.
100%. And as AI becomes more involved in software development, we need to make sure that we're prioritizing those things, robustness, reliability, just as much as we might prioritize efficiency or readability.
And that's where benchmarks like ProjectEval are so valuable, right? They're pushing the boundaries, but they're also showing us where those gaps are and where we need to focus our attention.
Absolutely. They're helping us identify those areas where we need to invest more research, develop new techniques, and build better tools to support this next generation of AI programmers.
This has been such a fascinating conversation. I feel like I have a much better understanding of just how complex AI programming is and how important these rigorous evaluation methods are, like
Right.
ProjectEval.
I'm glad to hear that. And I think it's also important to talk about the limitations that the researchers themselves have acknowledged.
Good point. Let's dive into those limitations, because no benchmark is perfect, and understanding those weaknesses is crucial for interpreting the results and figuring out where to go next.
Exactly. One of the key limitations is Project Eval's focus in its current form primarily on web development using the Django framework. Now, Django is a popular and powerful tool, but it's not representative of the full spectrum of software development out there.
So it's like saying, we've created this amazing test to evaluate chefs, but it only measures their ability to make pasta dishes. It doesn't give us a complete picture of their culinary skills, right?
That's a great way to put it. It's important to remember that what we're seeing with Project Eval might not necessarily apply to other programming languages or frameworks or types of software.
It makes me wonder if we'll see ProjectEval-like benchmarks emerge for other domains, maybe one specifically for mobile app development, another for data science, and so on.
I think that's very likely. As AI programming expands into new areas, we're going to need specialized benchmarks that reflect the unique challenges and requirements of each domain.
That makes sense. Now, you mentioned another limitation earlier, something about the output format.
Right. Currently, ProjectEval requires all AI agents to output code in JSON format. Now, this is great for standardization and evaluation, but it might not be the most natural or efficient way for some AI models to express their code.
It's like forcing a poet to write a sonnet in a foreign language. They might be able to do it, but it's probably not going to capture the full beauty and nuance of their original expression.
Exactly. And it raises the question of whether there might be more flexible ways to evaluate AI-generated code. Perhaps benchmarks that are less prescriptive about the output format and more focused on the functionality and performance of the resulting software.
That's a great point. It's a reminder that benchmark design is an evolving field. As AI programming techniques get more advanced, We're going to need to constantly reassess and refine our evaluation methods to make sure they're still relevant and providing useful information.
Couldn't agree more. We've covered a lot of ground, but there's still more to unpack.
I can't wait. Tell me more about these cascade and direct code generation approaches we touched on earlier.
Let's dive into that next. Remember, in cascade generation, the process is broken down into smaller steps, mimicking how a human programmer might approach it.
Right, like building a house brick by brick instead of trying to assemble the whole thing at once.
Exactly. And for many of the models tested, this actually produced better results, suggesting that a more incremental approach can be beneficial.
Which intuitively makes sense. By breaking down the problem into smaller, more manageable chunks, it might be easier for the AI to stay focused and avoid getting overwhelmed.
That's one possible explanation. However, there's a twist. Remember how GPT-4 actually performed better with direct generation?
Oh yeah, that blew my mind. It was like it could grasp the entire project in its mind and just generate all the necessary code at once.
Exactly. And that's what makes these large-scale models so fascinating. Maybe their sheer size and complexity allow them to approach problem solving in ways that we're only just beginning to understand.
It's both exciting and a little unnerving, right? To think we might be creating AI systems that can not only solve these complex problems, but do it in ways that are fundamentally different from how humans think.
No doubt. It raises some profound questions about the nature of intelligence and the future of human-machine collaboration. But for now, let's stay focused on what we're learning from ProjectEval about the strengths and weaknesses of current AI programming techniques.
Okay, let's get into the nitty-gritty. Where did the researchers see the most significant bottlenecks in the AI's performance?
One area that tripped up a lot of models was translating that natural language checklist of project requirements into a functional code skeleton. This skeletonization process requires a deep understanding of both natural language and programming concepts.
I'm picturing that classic game of telephone where a message gets distorted as it's passed from person to person. Except here, it's from human language to code.
Exactly. Any misinterpretations or ambiguities during that translation can have a ripple effect on the final output.
It just goes to show how important clear communication is, not just between humans, but between humans and AI. If we want them to build software that meets our needs, we need to be crystal clear in how we articulate those needs.
Right. And as AI systems become more sophisticated, we might even need to develop new languages or communication protocols that are specifically designed for this kind of human-AI collaboration in software development.
That's a fascinating idea. It's like we're on the verge of reinventing how we program altogether.
Right.
But for now, let's bring it back to ProjectEval. Were there any other areas where the AI seemed to hit a wall?
Besides those skeletonization challenges, many AI agents also struggled with elements of code generation that require a deep understanding of the project's overall structure and logic. Things like managing dependencies between different modules, ensuring data consistency across the application, that sort of thing.
So it's not just about writing lines of code, it's about understanding how those lines fit together to create a cohesive and functional whole. It's the difference between playing individual notes on a piano and composing a symphony.
Exactly. And that's where we see a clear distinction between what AI systems are currently capable of and the expertise of experienced human programmers.
It seems like we're back to that big question we started with. Can AI really code entire projects from scratch?
Based on ProjectEval, at least for now, the answer seems to be a cautious, not quite. AI has come a long way, but there are still significant hurdles to overcome before it can match the capabilities of human software developers.
But that doesn't mean AI can't play a valuable role in software development today. It's already automating tasks, suggesting code snippets, and even identifying potential bugs.
Absolutely. And as AI systems evolve, we can expect to see even more sophisticated applications in the workflow. ProjectEval, with its rigorous evaluation and detailed insights, is helping us chart a course toward that future.
It's like a compass guiding us through this uncharted territory. Speaking of uncharted territory, what do the researchers behind ProjectEval see as the most promising directions for future research? Where do they think the big breakthroughs need to happen?
One area they highlight is the need for AI systems that can reason about code at a higher level of abstraction. Most models right now operate at the level of individual lines or small code blocks, but to truly excel at project-level programming, they need to be able to grasp the overall architecture and design-making decisions that affect the entire system.
So it's like the difference between a construction worker who can lay bricks and an architect who can design the entire building.
Perfect analogy. It requires understanding not just the syntax and semantics of the code, but also the principles of software engineering design patterns, the best practices that guide the creation of complex systems.
That raises the question of whether we need to develop entirely new AI architectures or training methods to get to that level of sophistication. Perhaps models that are specifically designed to reason about code structure and hierarchy rather than just individual instructions.
That's one path researchers are exploring. We're already seeing experiments with things like graph neural networks and hierarchical attention mechanisms to enable AI models to better capture those relationships and dependencies within a software project.
It's incredible to think we might be on the cusp of a whole new era of AI-powered software development. But as we venture into this new territory, we can't forget the lessons we're learning from benchmarks like ProjectEval.
Right. Rigorous evaluation, user-centric design, a focus on robustness and reliability. These are all crucial for ensuring that AI systems become valuable partners in software development, not just glorified code monkeys.
Well said. It's clear that ProjectEval is more than just a test. It's a window into the future of how we build software. What else did the researchers discover about AI programming through ProjectEval?
Let's shift gears a bit and talk about a crucial aspect that ties into everything we've discussed today, the need for explainability.
Explainability, yeah, that's a big one. It's one thing for AI to write code, but it's another thing entirely if we can actually understand why it made certain choices. Especially if we're talking about, AI building these really complex systems that we rely on.
Absolutely. And that's where ProjectEval's multi-level input design is so insightful. By comparing the AI's performance at each of those levels, researchers can start to piece together its thought process, so to speak.
So it's like we're getting a glimpse inside the AI's brain, seeing how it takes that initial prompt and turns it into a working project. What were some of the key takeaways in terms of explainability? What did they learn about how the AI thinks?
Well, one interesting observation was that the models seem to be pretty good at generating those natural language descriptions of what a project should do. Like they can take those human readable requirements and put them into a more structured format.
So they're good at understanding the what, even if the how is still a bit fuzzy. It's like having an AI project manager who can nail the scope and features, but can't quite write the code themselves.
That's a great way to put it. And this ability to clearly articulate project requirements could be incredibly valuable even for human developers. Like, it could help streamline communication, reduce ambiguity, and make sure everybody's on the same page from the start.
It's like having an AI assistant who helps you, flesh out your ideas and make sure you've considered all the angles before you even start writing any code. Pretty cool.
Exactly. And as AI models get better at understanding both natural language and code, we can imagine them becoming even more integrated into those early design and planning phases of software development.
That opens up some really exciting possibilities. Imagine brainstorming with an AI, exploring different design options and getting instant feedback on, feasibility or potential trade-offs. It could really change how we approach software development.
Yeah, it could be a game changer, a future where development is much more collaborative and iterative, with AI augmenting human creativity and problem solving.
But let's not get ahead of ourselves. It's important to remember we're still in those early days of figuring out what AI can really do in programming. And ProjectEval reminds us that there are still some pretty fundamental challenges we need to address.
Right, we can't just focus on functionality. We also need to make sure that AI-generated code is robust, meaning it's not only working, but it's reliable, secure, and maintainable in the long run.
It's like this, I wouldn't want to live in a house that was designed by an AI that doesn't understand the laws of physics. It might look great, but it could collapse at any moment.
Exactly. And the stakes are even higher when we're talking about software that controls critical infrastructure, manages financial transactions, or handles sensitive data. Robustness is non-negotiable.
So how do we tackle this challenge? Are there any specific techniques or approaches researchers are looking into to make sure this AI-generated code is truly robust?
There are a few promising avenues. One is incorporating formal verification methods into the AI training process. This involves using mathematical proofs to guarantee that the code meets certain safety and security properties.
So it's like the AI is not just writing the code, it's also proving that the code does what it's supposed to do without any, unintended consequences.
Precisely. Another approach is to leverage the power of those large language models to generate more than just the code itself. Think accompanying documentation test cases, even explanations of the code's behavior.
Yeah, it'd be incredible. It's like having an AI that can not only write the software, but also write the user manual
Yeah.
and the troubleshooting guide and the technical specifications all at once.
Exactly. That kind of comprehensive output could be a game changer for human developers who need to understand, maintain, and build upon that AI-generated code. It could make the whole process so much more transparent and manageable.
It's exciting to think about how these advancements in explainability and robustness could lead to a future where AI isn't just a tool for programmers, but a true partner in software development.
A future where human creativity and ingenuity are amplified by the power of AI, leading to a whole new wave of software innovation. It's a future I am excited to be a part of.
This has been an amazing journey into the world of AI programming. Listeners, if you're as fascinated by this topic as we are, be sure to check out the show notes for a link to the original research paper on Project Evil. And for more in-depth discussions on the latest breakthroughs in AI and machine learning, you can visit our webpage. The link is in the bio.
Until next time, keep questioning, keep exploring, and keep pushing the boundaries of what's possible with technology.
From all of us here at Neural Intel, thanks for tuning in.